Okay, section 8.5 is writing and graphing exponential growth functions. Exponential growth function is y equals a times b to the x, where a is the value when x is 0, and b is your pattern. So I'll show you what that means momentarily. So if we are given this table with function values, we need to write the rule for the function. So the first thing you want to be able to determine is what is a. A is the value when x is 0, so this is a. And then we have to figure out what the pattern is between the y values. What is it doing every time? It's multiplying by 2. So then our exponential function is y equals 8 times 2 to the x, because 2 is your pattern. Okay, that's it. Next one. Identify your a first. And b is your pattern, multiplying by 3 every time. So once you recognize that, y equals 27 times 3 to the x. Okay, now we're going to graph. We are given the rule, identify its domain and range. So the first thing you're going to do is, I would just pick points, and 5 points is good. I'm always going to go from -2 to 2. And you just plug in those values for x. The first one is 1/4, second one's 1/2, 1, 2, and 4. And you can just plug those in your calculator to figure out what the values are. And we graph them. -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4. We want to connect those dots best we can. Okay, now identify its domain and range. Domain are all of the x values that work. Are there any x values that we could plug in there and not get a function out? No, so our domain is all real numbers. And the range, is it ever going to go below 0? No, so your range is just when y is greater than 0. Okay, graph these 3 different functions and then compare them. I'm going to call this one y1, y2, and y3. Just to simplify things, I'm going to make one big table. Okay, so we have y1, y2, and y3. So now we're going to plug all those in and get different function values. Let's go through and do y1 completely, graph it, and then move on to y2 and so on. So y1 will give us 3/4, 3/2, 3, 6, and 12. And I'm just figuring what those are ahead of time to save us a little bit of time. So at -2, it's 1 3/4. Oh, -1 is 1.5. 0, 3, 1, 6. And I don't have 12, so I'm going to just stop there. y2, function values are -3/4, -3/2, -3, -6, -12. So it's actually the exact opposite. And y3, 1/4, 1/2, 1, 2, 4, which is what we just did. So what do we notice if we compare these two? Or these 3, I should say. The blue and black are just opposites. They're flipped over the x-axis. And it looks like black is almost steeper. Maybe it might not be steeper, but it's just up a few. That's just based on what the value is when x is 0. Notice that the red is 1 and the black is 3. So that a value, that just kind of moves the function up, it looks like. Okay, let's do a couple practice problems. Graph 5 to the x. It's 1/25, 1/5, 1, 5, and 25. Okay, so it should be virtually touching the x-axis and going up very dramatically. Identify the domain and range. Domain is all real numbers because there's no x values that we couldn't plug in. And the range is bigger than 0. Compare with the graph to the x. We just did to the x, so I'm going to graph that one in red. Since we just did that one a couple times, I don't need to re-figure out what those points are. And then I'm going to do the new one in blue. Okay, so we have negative 1/12, negative 1/6, negative 1/3, negative 2/3, negative 4/3. This one's going to be very small, it looks like. Negative 2 is negative 1/12, which is very close to the x-axis. Negative 1/6, negative 1/3, negative 2/3, negative 4/3. This one's very gradually going down. Okay, so even though the x is the same, that negative 1/3 out front really changed what this looks like. Okay, now we have an exponential growth model. Our model is y equals a times 1 plus r to the t. Now a is initial amount. This will be for word problems. R is our growth rate, and that has to be a decimal. And t is the time period for our problem. So we're going to use that model in all of these problems on the following page. So we have a 1953 Hudson Hornet convertible. They sold the car at an auction. It was bought in 1984 when it was $11,000. It has increased at a rate of 6.9 per year, 6.9%. So if we're going to use, this is our model again. So write a function that models the value of the car. The a is the initial value, so that was 11,000. 1 plus the rate, which is 6.9%, but we need to write that as a decimal, which is 0.069 raised to the t over time. So we just keep the t as it is. If the auction took place in 2004, what was the approximate value of the car at the time of the auction? That's when we're actually plugging something in for t. If it was sold in 1984 and if the auction was in 2004, then our t is going to be 20. It's been 20 years. So 11,000 times 1 plus 0.069 to the 20. We all have calculators. That would be $41,778 at the time of the auction in 2004. If you put $250 into a savings account that earns 4%, compounded yearly, you do not make any deposits or withdrawals, how much will your investment be worth in 5 years? Your initial amount's $250. 1 plus your interest rate 0.04 raised to the 5th. You'll have $304.16 in 5 years if you invest that much. Okay, and that was section 8.5.